I'd like to introduce our keynote. Mobile technology expands to new horizon, and our keynote speaker, Linley Gwennap. Linley Gwennap is president of the Linley Group, principal analyst for mobile, one of the most respected analysts in the microprocessor industry. He's followed the industry for more than 20 years, starting as a processor designer at Hewlett-Packard. He later worked in PA risk marketing and then became editor-in-chief of Microprocessor Report and vice president of Micro Design Resources before founding the Linley Group in 1999. Please welcome Linley Gwennap.
Great, thank you, Roy. Sure. So I'm the token non-MIPI speaker here today. Peter and Roy asked me to come and try to give a bigger picture of what's going on in the semiconductor industry with a focus on the kinds of technologies that you guys are interested in. So I'm going to be talking about the mobile market and some of the trends that we're seeing there. But I also want to touch on some other markets where we're seeing mobile technology being used, such as the wearables space, IoT, and even the automotive market. But starting with the mobile market, this is the situation we've been seeing in smartphones, where the market had been growing at 20, 30, 40% per year. Everybody was very excited. Now the growth rate has fallen off a cliff. And we're expecting single-digit growth over the next several years. And of that growth that's happening, most of the growth is coming in the low end in developing countries. So more of the low-cost type of smartphones, and the growth is coming from some of the big Chinese smartphone suppliers. But the problem is that smartphone penetration is leveling off, and so we're no longer seeing the kind of explosive growth in that market. In terms of the vendors, Qualcomm is been the leader in smartphone processors for a long time, but we're seeing renewed competition in that market, and MediaTek and Spreadtrum have been growing quickly, and so we'll see a really tight race this year. This is our forecast number for this year, but we're seeing a really tight race, for that number one spot. And as the smartphone growth is happening at the low end, that really favors companies like Spreadtrum, who are very focused on that low end market. In the IP space, a lot of the IP makers now are focusing, of course, on the smartphone market and licensing CPU cores, GPU, DSPs, NOCs, lots of IP out there. Trend that we're seeing is more companies trying to design their own IP rather than just using standard cores. So we see companies like Samsung and Apple that are designing their own CPUs, companies like Qualcomm and Intel that really design almost all of their own critical IP. So we're seeing more focus in that regard. On the types of cores that are being used, a key trend that we're seeing is toward heterogeneous computing, which is combining different types of cores for the compute requirement. So instead of just running everything on the CPU now, whole applications are being shifted off onto the GPU, the DSP, image processors. And the real goal here is to improve battery life by doing the compute on whichever core is the most power efficient for that particular task. So, and the standards are now evolving with the new OpenCL to more tightly couple these heterogeneous compute units together to allow even greater use of this type of computing environment. And this is really causing the software to have to be more flexible in order to deal with all of these different units. 5G, we're hearing a lot about 5G, but really it's going to take a while to get to market. The standards effort is just getting kind of going, and then there'll be testing and deployment. And so we expect the real 5G products to come out around 2020. There'll be some pre-5G products coming out sooner, but those are mostly focused on fixed broadband deployments from companies, operators like Verizon. So if you're looking for a 5G smartphone, really not going to happen until 2020 or even later, depending on how things go. And then another trend we're seeing in smartphones is sensor fusion. Lots of sensors coming into the smartphone. This chart shows the growth just in Samsung's phones, and been adding sensors every year, and so the hardware is now trying to pull all that sensor data together, interpret it in a lower level processor before it gets shipped up to the main CPU. Again, the focus is on extending battery life. So this is some of the things going on in smartphones. Then if we look at wearables, the wearables are using some of the same technologies that we're seeing in the smartphones and just kind of downsizing and moving down into some of these wearable devices. So of course the smart bands, the fitness bands are pretty popular today. We saw nearly 50 million of those shipped last year. We'll see significantly more shipped this year. Fitbit, of course, is the most popular, but also Xiaomi in China is shipping very inexpensive products. Smart watches are growing in popularity as well. I mean, even though the Apple Watch hasn't been as big a hit as many people had hoped, it still sold about 10 million units last year. And if you throw in some of the other smart watches, about 24 million smart watches last year. So there is a market here. It's certainly not as big as smartphones, but it is catching on and starting to grow. And then the processors that are going in here are some using the same technology from the smartphone. So for example, Apple uses the Apple processor that it developed for the phones and just kind of shrunk it down a little bit and put it on this small circuit board to get it into their smart watch. The Android watches mostly use a Qualcomm Snapdragon chip from the smartphones. So taking the same processors and the same chips, and then the same interfaces tend to follow along with those chips. Other wearables are using off-the-shelf microcontrollers from ST Micro and Cypress and other companies to minimize costs. So there's sort of two different tracks going on in terms of which processors are getting used. And now we're starting to see some chips that are really focused on this wearable space. You know, I'm showing one here from MediaTek, and it's a pretty impressive that it combines the CPU, the memory, the display drivers, the wireless Bluetooth interface here, a bunch of analog stuff, all on one chip. So in order to meet the kind of strict cost goals, you know, particularly for some of these, you know, very low cost wearables, putting everything integrated on one chip is going to be more and more common. So trying to get all the right technology into one place is a trend that we expect to see. And then looking into the future, you know, this is our forecast of the wearables market. You know, we see the fitness bands are very popular today. We think the watches are going to, you know, become the more popular method of wearables in the future as the price comes down and the capability of the smartwatch gives you a lot more things to do and hopefully not cost that much more than the fitness bands. So we see, you know, maybe about 10 to 12% of smartphones, you know, will be sold with smartwatches. And if you do the math, then that works out to over 100 million wearable devices, close to 400 million wearable devices in 2020. So we see a big opportunity here, and then leveraging a lot of the same technologies that come from the smartphone, you know, down into these wearable devices. IoT is another market that's growing quickly. You know, just a quick overview of what is IoT, the Internet of Things. You know, what does that mean? a lot of people use that term in different ways. So, we kind of divide the IoT into three pieces. You've got the client device, which would be like the smart thermostat that sits in your house, smart washing machine, whatever device that is connected to the internet through some sort of wireless, typically a wireless connection. And then that device, through the wireless connection, would connect to some sort of gateway. Perhaps it's your Wi-Fi access point in your home, or it might be in an industrial setting, some sort of wireless gateway. And then that gateway would transition the data through the internet into some sort of cloud service where the cloud allows you to then access that device maybe from your phone or remotely from the office, wherever you happen to be. So you've got the three pieces then. You've got the client, the gateway, and then the cloud service. So the volume is going to be in the clients. And what we're seeing then is these, again, specialized, highly integrated SoCs that are being designed to meet the needs of these IoT clients. So this is an example of a Silicon Labs device that again, combines the CPU, the memory, the radio, the analog, a lot of components together to meet the kind of low cost points that are needed in IoT. We also see a lot of focus in IoT on reducing power as well, because a lot of these devices, you might put a smoke detector or security sensor in your home, and it just runs off of a small battery for months or years. So that device has to use very little power, and integrating everything onto one chip helps minimize the power that's being used. So a lot of work is being done to create the right kinds of SoCs to meet the needs of these IoT clients. And then, of course, the IP vendors have to tune their processor cores as well to meet these, the lower performance requirements in IoT, because these devices are fairly simple. A smoke detector doesn't have to do much. Thermostat doesn't have to do much. So you can use a pretty simple CPU. A lot of these devices, if they have a screen, the screen is pretty small. If it's on your wrist, or if it's maybe just a small panel on your wall. So the GPU can be simpler. So now we're seeing smaller, simpler, lower power IP cores being designed as well. So we have a more complete forecast of what the IoT is going to look like. This is one chart. 5 years from now, we really see the big opportunities being in the consumer space. We hear a lot about industrial IoT and smart cities and smart factories, but there's a lot more homes, there's a lot more consumers than there are factories. So we see a big opportunity once the right use cases are available, that there'll be a lot of these kind of smart devices, smart appliances, and smart security, smart lighting. These kind of things will be popular in the home, and and then that will drive. We're seeing about 2 billion units shipping in 2021. So we've heard people talk about 50 billion, 30 billion units. I mean, this we feel is a more realistic number, but it's still about the same size as the smartphone market in that time period. So a lot of units going into the IoT, big opportunity here for some of the mobile technologies to expand into this new and rapidly growing market. So the last market I want to talk about then is the automotive market. This is another market where we see a lot of rapid growth happening, and particularly in two areas that my team is focusing on. The in-dash system in your car, what's in the industry called the in-vehicle infotainment system, is becoming more popular as the rear camera is being included in many more cars, so you need that little screen in your dash to see what's going on. And then once you get that screen there, let's put a touchscreen interface on that. Maybe we can have some navigation. We can control the radio and things like that. So that's becoming more popular, and we expect that to be in more than half of all cars. And then these active safety systems, which are referred to as ADAS, are also becoming more popular, although a much smaller base today. But you may have heard about automatic emergency braking, which detects if there's a car in front of you that's suddenly stopping, will automatically brake your car to help prevent a collision. That's going to be in all U.S. cars in 2022, and also, of course, in many cars sold in other countries. So, and then there's something called lane keeping assist, which helps keep your car centered in the lane, active cruise control. So these kinds of functions are becoming more popular because people are very concerned about the safety as they're driving. And we've seen them mainly in high-end cars, a BMW, Mercedes, but we're actually seeing now some of these active safety features available on many mid-price cars, and even low-end cars like the Honda Civic. You can upgrade and add some of these features for as little as $1,000. So we see a big opportunity for growth in these active safety systems, and then even autonomous cars, which if you're hanging around Mountain View, I'm sure you're very familiar with autonomous cars that are driving by from Google all the time. And the progress is being very quick on those. We expect to see some fully autonomous cars for sale probably by 2018 or so, just a couple years away. And of course, the initial models will be very expensive, but the cost will come down over time, and there'll be more and more of these autonomous cars available. And these require a lot of cameras and sensors to make all this happen. So, that's not good. So these in-dash systems are actually, very similar to smartphones in the sense of, you need a processor that needs to run a lot of code. You need to have some kind of screen that probably a touch screen to take user interface, and then you need to also connect with the camera, at least the rear view camera, if not some other cameras surrounding the car. One of the things that is starting to come in more vehicles is something called surround view, where you actually have 4 to 6 cameras around the car pointing in all directions, and then the graphics processor inside the main processor chip is able to synthesize all of those views together, and it actually creates this overhead view. Even though there's no overhead camera, it kind of creates an overhead view of what's going on around the car. So that's a very cool feature, and it's available in some luxury cars today, and is starting to become more popular. And then that obviously requires fairly powerful GPU, fairly powerful CPU, and then interfaces to all of these multiple cameras around the vehicle. So we're seeing companies like NVIDIA, NXP, Qualcomm, taking chips that used to be used in smartphones and then repurposing those chips for use in these infotainment systems. So that's a big opportunity in the car. And then another trend we're seeing is the digital dashboard. If you've been like in a Prius, the whole dashboard doesn't have any gauges, mechanical gauges anymore. It's just a big screen, and displays information. So now not only is this processor driving some sort of screen in the center console of the car, but now it's also driving a second screen in front of the driver, replacing the dashboard, and even in some cases controlling the screens in the rear seats that provide entertainment for the people in the back. So now these systems are requiring not just a smartphone processor, but a pretty powerful high-end smartphone processor with lots of display connections, lots of camera inputs, and taking advantage of some of the same technologies that are in the smartphone. Oops, there we go. So the safety systems then are another opportunity, and we are seeing not literally the same chips from smartphones, but some of the same technologies being used. Companies like NVIDIA, NXP are taking these same chips that were originally derived for phones and adding some other capabilities to target these safety systems. And the key thing now in these active safety systems is the vision processing. So typically what you have is a camera that's facing forward, or perhaps multiple cameras that's looking at the road, looking at the vehicles in front of you, and actually having to interpret what's in front of the car and say, okay, that's where the lane markers are, so I want to keep the car centered in the lane. There's a truck in front of me. I want to maintain a certain distance, between the car and the truck up ahead. And if that distance starts to shrink, I may have to slow the car down. So this requires some very sophisticated vision processing. It also, of course, requires bringing in one or more cameras into the processor in order to process all of this visual information. There may be other sensors as well that have maybe radar, LiDAR, ultrasound, and all of those sensors have to pipe their data into the processor as well. So there's a lot of visual data coming in, a lot of sensor data, a lot of processing going on in order to make these systems work. And as things become more sophisticated and more complicated, there's just be more and more cameras involved. So ultimately, there we go. Ultimately, then you end up with these autonomous vehicles, and we're already seeing things like the Tesla Autopilot that allow the driver to kind of let the car control itself with appropriate supervision. And so then at some point you can kind of get rid of that appropriate supervision and have the car pretty much take care of itself. But in order to do that now, you really do have to have a lot of cameras around the car, a lot of other sensors like this LiDAR system. And we expect to see a lot of progress being made over the next, just the next 5 years, leading to fully autonomous vehicles that can drive themselves in a full range of conditions, which is Ford is promising to have by 2021. Other companies have made similar commitments to have autonomous vehicles out in the next few years. So even if the initial cost will be fairly high, we're certainly seeing a lot of interest from taxi companies. Companies like Uber and Lyft have already made alliances to use autonomous vehicles. If you think about what they're paying drivers, paying $10,000, $20,000 up front, for a self-driving vehicle will save them a huge amount of money. So, and then even for personal use, I think a lot of people are going to be very interested in this kind of technology just to save the time or reuse the time that they're driving right now. So just to conclude then, as we saw, the smartphone growth is slowing, but it is still a very big market, very successful market for mobile technology. But we do see mobile technology moving into some of these other markets. Wearables, we see a big opportunity in smartwatches. And then in IoT, the biggest opportunities are going to be in the smart home, things like smart appliances to bring that technology in. And then in the automotive market, we expect more than half of the cars will soon have these in-dash display systems, as well as an array of cameras and displays that are being driven through these mobile processors using mobile technology. So we have time for a few questions. I'd be happy to take some. If anybody has anything.
Linley, thank you.
All right, thank you.
Thank you very much. It's awesome.